Hello there, folks. Hey, this video is going to be another one about indirect addressing. I have one currently, I believe, on the site, a little older, and this one I was making something new and trying some different things. So in this example, what I'm doing here is over in the left side of communications. I just want to show you that under Modbus protocol, I've got four different slaves, a slave 91, 92, 93, and 94. Those are numbers I use for something else, and they've always stuck with these HMIs, so that's where the 92, 93, whatever comes from. They all have different IP addresses. You can see right here on my local network, and they're all using port 502. They're just HMIs set up as Modbus slaves. No big deal. And if I go over to data tags, I want you to notice that I've got different categories or folders of tags here. And if I happen to expand, for instance, the slave 92, I've got two folders here that called tags from the slave and tags to the slave. Notice something here. If I go to the tags from the slave, you can see that I've got them broken down into integers, reals, and flags. So if I expand the integers category, notice that they're all green here. And if I click on the data tab here, let's see if I slide up here. Oh, you must be kidding me. So if you notice here sometimes in Crimson, I can't see the mapping here. So I'm going to close Crimson and reopen this, and that'll fix that problem. I don't know why it does this on certain PCs, but let me close it and reopen it. All right, so once I close Crimson, reopen the application, I can once again slide all the way top and see the source. So notice that the integers are going to 40,001, 2, 3, and 4. I also have some reals in here that are mapped to 40,100, 102, and I got some flag or binaries that are mapped at the 200 register, actually the 200 and their bit numbers. So notice that all these are green. I want you to notice that because I've got them set up at least as read-only. They're all inputs, so no big deal. That's why they're green. I also have a category in each one of my slaves called tags to slave. And if I look at these guys, notice they're mapped to the 300 registers, whereas these up here were mapped to the 40,000. This is 40,300, no big deal. But I just want you to notice I got these set up as read and write. So there they are there. If I go to the reals, I put these at the 400 series and the flags at 500. But notice they're red because the axis is read and write. Those categories are all the same for all of my slaves. If I expand all my slaves going down, they're exactly the same mappings. So you could pretend this could be your device out in the field, or you got multiple devices, exact same. The only difference happens to be is the name of that device or so forth. That's what I'm doing here in this example. And then I have another category called dynamic tags. And I want you to notice that in the dynamic tag mapping, I've got the same categories or same folders, if you will. So if I expand these, you'll see the same listing. However, here's a little bit difference. On the ones that are tags from slave, notice out here in the source, I have a complex function called pointer function. Let me hit the edit button here and expand this. And I want you to see that I'm doing this huge, long return string here. And I'm using a function called getIntTag. And you might wonder, what does that mean? Well, if I go to the lower right-hand side of Crimson, click on System, expand the functions tree, and then slide down and expand the tag data tree, you can see there are some green diamonds and there are some red diamonds. The green diamonds are read-only or input type thing, and red is writable thing. So here I have a function called getIntTag. So if I happen to go over here and right-click on this and go Show Help Info, it'll open up the PDF, and if I make it a little bigger so we can see it, you can see that this returns a value of the tag by the index. The index can be found in Crimson Configuration Tool or find tag index. So that means, let me shrink that down, that this is going to find an index based on this category here of this whole function. Slave, other tags. So I've got a folder called other tags that gives a number and tags from slave, which happens to be, if I do this, let's pretend here. If you notice here, slave underscore, so there's slave underscore, and then there's another function here called other tags. Let me expand this. So I have a function here called slave number, which is just an X, means it's a integer number. So that becomes slave underscore whatever number that happens to be. So let's say it's 92. That puts us in this location. And then I do a plus dot tags from slave. So here's dot tags from slave. That's the folder index into there. And then if I slide over a little further, you'll see I do a plus dot another integers. That's that folder. And then I do a plus int1, which actually gets to this guy right here. So that's the function that returns that value on that particular thing. Let me go ahead and close that down. And the same goes for all the rest of these. And all of the reals are the same, except for the reals, a little bit different on the reals. We're using a get real tag for that function instead of get int tag. So we're doing that there. And also the flags, those show up as a integer value. So we're using the same get int tag, find tag index there. No big deal. However, things get a little bit different when I go down to the tags to the slave, the tags I'm writing to the slave. So if I look at this, I want you to notice you got the same complex program here, same exact code in this part here, but where it's a little different is on this one down here in the on right, we use the pointer function. Let me slide back up here and say this a little different. I got to show this to you. So if I click up here on the yellow ones, notice I'm not doing anything down here in the data write on those because those are read-only or inputs, if you will. If I go down to the tags to the slave, click on the red one, I have here this complex. I put the same name, pointer function. I probably should have changed it, but I have the same name here. This is the same pointer function here that happens on the read. It's the same exact thing. It's the same function there, no big deal there. But down here, it's a little bit different here on this one. Let me show you. If I click the edit button, you can see I'm using the set int tag or set, it could be the set real or set int, or set string, but I'm using the set, not the get. Just want to point that out to you. And then here's where it's really different. Same exact nomenclature, but way at the end, I have a comma data. That's where things are different. Like, where does the comma data come from? That's the part that's a little bit deep here. So the data that you see here, this word data, actually comes from when the pop-up on the screen, there's a pop-up that comes up to enter a number. That becomes the internal tag called data that gets written to that particular thing on that function. And those are the same. If I slide down to reals, exact same function, except for I'm using the set real instead of the set int. And if I go all the way in here, there's that data again. And if I do the same thing on the flags or the booleans, you'll see the exact same thing. Wait a minute. I didn't click. Hold on. I got to slide down here to this part here, right here. There we go. Set int. And right at the end, there's the data. So perfect. So let's show this in work. And really what I'm trying to show in this data or this video is how the indirect addressing works and when does it get called and so forth. So in the HMI program, I have some screens or display pages that are actually just showing the raw data from each folder. So all I did here is I drug those tags on the page and made it. And what Redline does is anything that's on a display page normally is when we're polling that or trying to get that data from that device. If it's not on a page or the tag's not being used in the DataLogger or somewhere else, then why bother trying to retrieve that data because we're not asking for it. So Redline tries to show you the data you want to see on the display page because that's what the operator is standing in front of, and we're going to try to get that data as fast as possible. So all these pages are showing that data, but then I got a page called Indirect Addressing. Now this page is a little different because even though it has the same tags here, it's actually using these tags on this page. It's using these dynamic tags here. So if I right click on this guy and go to jump to right here, see how it says dynamic.tags? Those are using that particular tag. Same goes for any of these that are set up for data entry. If I right click jump to, you'll see they're going to dynamic tags as well. So those are the units there. But what's unique here is that these tags only get updated if I have some program that calls the real map tag over here, the ones that are actually pointers at it. So I go over here to programs. I want to show you something. In programs, I wrote a couple programs here. Particularly, I created some polling programs that do nothing more than poll the real tags and put them in some internal registers and do nothing with it. But this simple logic will cause the HMI to pull that tag when I'm looking at that display page. Without this, then I only get a refresh of whatever it showed last time it was pulled, and that's it. It's not real data. So this causes the HMI to refresh. And then I've got a indirect addressing pointer. I got a case statement. I got another YouTube video that shows that. So if you search for case switch statement, you'll see how this is used. But in this case, well, that's a weird word. But in this situation, over here on display pages, this little slider right here, if I right click on this jump to, you'll see it goes to the slave number, and it actually does the case depending on what we're looking at here. So let's go ahead and try this out and see what happens here. And also, I'm going to prove that this does polling of the tags because I've got a blank page that has no tags on it. So we'll see no activity via what I'm going to call Wireshark. And then if I look at any of these, you'll see it. But if I go to this one, if I'm not polling one of those, we won't see any traffic. And I'm going to show this to you because over in Web Server, on the Features tab, I do have enabled all the system things down here, particularly the packet capture, which will allow me to use Wireshark to show this happening. So let me go to the web browsers here. I want you to notice I got two tabs of the web browser looking at the exact same HMI. The one on the left I'm going to use as the remote view to show us the remote display page on that particular unit. And then the one on the right, I'm going to use the system diagnostics to show us the Wireshark captures of that. So we'll refresh this. We'll refresh this guy. I don't know why it's saying that. That's just absolutely wonderful. Sometimes I think this duck DNS sucks. You know, maybe somebody needs to tell them. All right, give me a second here. Okay, so somehow I finally got it refreshed correctly. So here it is on the left. If I go to slave 92, you can see there's real data coming across from that particular HMI. And if I go over here to the right one, by the way, I went to system diagnostics. If I go to network capture and go down here, I'm going to do a specific port. 502 is Modbus. Let me do this. Let me put this back. I'm going to go here to blank page. So there's nothing going on. We shouldn't be looking at anything. So if I hit the start capture here and then do a stop capture, slide down, notice 24 bytes. That's pretty much a blank Wireshark capture. There's nothing in that frame, period. There is nothing. I seriously, I can probably download it. It doesn't show anything. So it doesn't matter. It's 24 bytes. Now, if I hit the back button here and go to slave 92, I am specifically polling this device right now. So if I hit the start capture, and then I'll go ahead and stop the capture. There we go. Let me stop it. Look, there's a ton. There's already 22K of data. I can download that, but I can assure you there's a ton of Modbus traffic happening right there between that HMI and the slave 92. As it should, because I'm polling this as fast as I can. So if I hit the menu button here, and it doesn't matter if I go to another one, but if I go to the indirect addressing page, this one right here, let me go, notice right now nothing's going on. Let me do a start capture and do a stop capture, 24 bytes, there's nothing there. So if I go ahead and alter this, so here I have a slave number 91, and all it does is do the counting here. None of these are being updated. Just to prove, I do a start capture, hit the stop capture, look, 24. Nothing happening. If I go to the next one here, now look, now it's real time. So now if I hit stop capture, start capture, stop, you see I got 20K. It's all kinds of data there. And notice right now I'm looking at slave 92, right? So if I hit the menu button and go back here to slave 92, notice that the tags written right here, all over here, are either 0 or all off. If I go back to my indirect addressing page, I have that thing resetting, but if I go to 92, there it is. If I put in here on this guy, 1, 2, 3, oops. Maybe I just put in 13. How about this one? I don't understand why that. There we go. All right. And how about a real number here? Let me go here. 12.34. Boom. If I hit the menu button, go back to this here where they're mapped. Look, there they are. They're actually real-time updating through the indirect page. Again, if I start the capture here on the indirect page, nothing's being going. Go ahead and stop it. You can see 24. If I go to this guy here, there they are real time. They all updated correctly. If I go to the next one, these are all 0 because I haven't done anything in here. Same goes for the rest. I do have a manual pointer button here that generates, based on what I'm looking at here, it will create just an example to look at. But anyway, the point being of this whole thing is that even though the display page is using indirect addressing, you need something in the background that's going to update those tags or call it. Now, in the previous video, I was using the DataLogger as a to-do list. There's some people at Redline have told me to use a triggers tab and do a NoOp, but I found that all of that creates additional traffic, and I'm trying to limit this to where I only see the tags I want to see here that are called. So by doing this case statement here, couple that with my program that fills in with internal, this program only gets called from the indirect addressing. So when that case is 91, 92, 93, that's the only time that program is called. Oh, and one more thing on these programs. On the Properties tab, I have them set to same as caller, run anyway, and I've got them set to read when executed. All of these are set to read when executed. Whereas this one is read when referenced, means this program, the indirect addressing, is only referenced. And by the way, you might ask, what do you mean, where is it referenced? Well, if I go to display pages, I'm on the indirect address page. If I right click on this page and go to properties, notice that on the action tab, when I first come into this page, I always set the slave number 90. That's why you saw this guy always go back to 90. And then on update, which is in the background, I'm calling that program as fast as possible on update. Now, if I slow that down to on tick, let me show you something. So if I go back to here, I want you to notice these are cranking away fast. See that? Because I got that running in the on update. Let's see if I change that to, instead of running on update, let's run that on tick. I want you to see the difference. So I'm going to go ahead and highlight this, cut, paste it up here like so, boom. All right. And I don't know if I got this set up right. Let's see if I go ahead and download it here. Okay, so I'm using something there. Let me go to link, options. We'll try the old TCP. See if I got the right IP address and cross our fingers. There we go. Oh, I love it. Things work. Now watch. I want you to see something different this time. At least I hope anyway. And I got my, this should be coming up. And it looks like it's up on the real screen there. Should be refreshing. Okay, let me hit remote view. All right, so now if I look at remote view, now that I'm doing that, if I go to indirect addressing, this time I got that program being called once tick. So if I go ahead and move this to 92, I want you to notice that you can see it's updating, but really it's only updating once a second, whereas before it was on as fast as possible, really, the background. So that's the big difference between calling that program on tick, which is where it is now, versus on update. But anyway, that's the purpose of this video, is to show you really the indirect addressing and how I wrote some programs to call those, or really update some internal registers instead of using a huge data logger. Or like I said, somebody else at Redline had recommended that you could use a triggers and do a NoOp. But the problem I had with all of those is that it's then being called all of the time. Whereas this method, I'm only hitting these particular tags when this page is being displayed. Thus, I think, making things run more efficiently. That's just my opinion. Anyway, if you want to copy this database or anything, don't be afraid to send me an email and let me know. Tell me that you want the HMI 96 master indirect addressing. I'll send you the database. Hey, thanks a lot, folks. Have a great day. We'll see you later.